I have a standard coaxial signal splitter. This little metal block is usually used to divide a TV signal, but today it will serve as the core chassis for our homemade antenna. Next, I take a piece of standard white coaxial cable. I'm measuring it carefully because precision in the length helps with optimal signal reception. Then, I use my pliers to cut it exactly in half, giving me two equal lengths that will become the receiver arms of our antenna. I'm going to strip the outer insulation off one end of each cable using a utility knife. I need to expose the solid copper core inside. This inner wire is crucial because it's the actual conductive element that captures the radio waves from the broadcast towers. I'm attaching an F connector to the stripped cable. I'll wrap these stripped ends with some red electrical tape. It provides a bit of extra insulation at the base of the connectors to prevent any signal interference. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Moving on, I strip a much longer section of insulation off the opposite ends of both white cables, removing the outer jacket, the braided shield, and the dielectric insulator to leave a long piece of bare copper wire. This is where the magic happens. I'm screwing the taped cable end into the input port of the splitter. Then, I carefully bend the cable to form a loop. I am securing the bare copper wire into the small hole next to the splitter and tightening it. For the remaining wire, I'm securing the cable to one of the two output ports and repeating the securing process. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. This specific loop design creates a dipole effect, which significantly boosts the antenna's ability to pick up frequencies. To make this setup practical, it needs a stand. I take a small metal L bracket and attach it to the back of the splitter. Then, I grab a piece of scrap wood to act as a base and screw the bracket firmly into it. This weighted base is important because it keeps our antenna standing upright and stable for the best possible reception. Our antenna needs a way to send the signal to the TV. For that, I'm taking a longer piece of black coaxial cable. Just like before, I carefully strip both ends to expose the inner conductor, preparing them for the metal connectors. I'm putting a standard straight connector on one end and a right-angled L connector on the other, which is perfect for fitting into tight spaces behind flat-screen TVs. Once secure, I screw the straight end onto the central out port of our splitter. Our homemade antenna is now fully assembled. As you can see on the screen, my TV currently has no signal. I'll take the connector and plug our homemade antenna into the back of the TV. Instantly, we have a crystal clear, high-definition picture. Look how perfectly it works. To prove it's really our DIY antenna doing the heavy lifting, I'll unplug it. And immediately, the signal drops out completely. Let me plug it back in one more time. The signal comes right back, strong, vivid, and perfectly stable across multiple channels. We are getting free, high-quality TV using just a modified splitter and some leftover cable. This DIY device proves that with a little creativity, you can achieve amazing things. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what other unexpected tools you'd like to see me create. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching. See you in the next video.